Now, coming to some other reactions. We have already done nucleophilic addition reactions. With elimination of water also we have done. We have done oxidation reaction. We have done reduction reactions. Now we will come to the reaction due to the alkyl group. Alright, alkyl group. Now here what we'll do, we'll go for halogenation reactions. Let us say CH3CHO and we will take chlorine. You know chlorine is highly reactive in nature. For that purpose we are taking here chlorine because it can replace a hydrogen atom. And what is going to form? CH2Cl CHO. And that chlorine reacts with hydrogen to form HCl. So it is called as, the name of the compound is monochloroacetaldehyde. Monochloroacetaldehyde it is known as. Fine. Now if you take excess of acetaldehyde, excess of chlorine if you take it, that is 3Cl2 if I take excess of chlorine, it will replace all the hydrogen atom here and it is going to form CCl3CHO plus 3HCl. Alright, CCl3CHO, all the hydrogen atom is being replaced by chlorine, all the alpha hydrogen atom rather I should say, is being replaced by chlorine to form CCl3CHO, which is known as trichloroacetaldehyde. It is also called as chloral. The other name for trichloroacetaldehyde is known as chloral. We can say that. Clear? In this way, you can do this reaction with acetone also. You can do this reactions. Like suppose I can take here CH3, that is nothing but COCH3. I can take it. Now, let us take here Br2. Same thing. Chlorine and bromine, little bit of difference in reactivity. Bromine is less reactive, chlorine is more reactive. So it will replace the hydrogen atom. Alright, from here. So it is going to form CH2Br, COCH3 plus HBr. Now why is it so? Because chlorine, bromine, all these have great affinity for hydrogen. So hence they replace it. It is undergoing replacement reaction here. Substitution reaction here it is undergoing. Alright? Clear? And of course it is a single bond. Carbon-carbon single bond. Saturated, you know that. So hence it undergoes substitution reaction. So earlier we used to do the nucleophilic addition reaction. There the reaction was due to the functional group. Understood? So here the functional group is not participating. So here it is halogenation reaction. This is not what you can say the nucleophilic addition reaction. So it is a halogenation reaction. And halogenation reaction is a substitution reaction. Got it? So hence for that particular purpose the hydrogen atom is being replaced by chlorine and bromine. The alpha hydrogen atom we can say that is being replaced by, and hence we get the corresponding substituted product, we are getting it. Fine. Now next, after that we will come to condensation reactions. Condensation. What do you mean by condensation reaction? Condensation reaction means, you may write it down, that is when two smaller molecules combines to form a large molecule, a macromolecule, with or without the elimination of micromolecules is known as condensation reaction. Or you can say in this way also, when two micromolecules, instead of smaller molecules, you can just change the word with micro. When two micromolecules, meaning is same, smaller molecules, combines under certain conditions, alright, they undergo what you can say a bigger molecules. They combine and they form a bigger molecules, a macromolecules. Alright, with or without the elimination of smaller molecules. Now here the smaller molecules means what? It can be water, it can be HCl, it can be SO2, it can be CO2, it can be ammonia. So with or without the elimination of the smaller molecules, with or without, either the smaller molecules can be eliminated or may not be eliminated. But it will form a macro product, a bigger product. The smaller molecules combines to form a large molecule, a macromolecule. Alright, that is called as condensation reaction. Okay, so this is known as condensation. Now, the next is that what are the different types of condensation reactions are there? We are going to study in this particular chapter. That is aldol condensation, Cannizaro's reaction, Tischenko reaction, alright, Perkins reaction. But you will find certain reactions are given by aldehydes, but it is not given by ketones. I will tell you which are those. So first we are going to start with aldol condensation. Aldol. Now, you first write it down. What are the conditions required for aldol condensation? What is the condition required? First of all, the compound should have an alpha hydrogen atom present in it. the compound should have. That is alpha hydrogen atom. So definitely there should be an alpha carbon atom. I said which is alpha. After the functional group, as you can see, after the functional group, this carbon is called as the alpha carbon, and the hydrogen which is attached to it is known as alpha hydrogen. Very simple. Alright, so the compound should have an alpha hydrogen atom attached to it. Alpha hydrogen atom must be there. Alright, this is the first condition. The second condition, the reaction takes place in presence of dilute alkali. For example, it can be dilute NaOH, dilute KOH, dilute Na2CO3 or dilute K2CO3. We can also take dilute barium hydroxide also. That also can be taken, even if it is not an alkali, but it can be used. Alright. So in this way, the reaction takes place in presence of dilute alkali and alpha hydrogen atom must be there. Alright, it must be there. So these are the two conditions. Alpha hydrogen atom must be there and the reaction takes place in presence of dilute alkali, so to say. Then only this reactions is going to take place. Alright, the condensation reaction is going to take place. Which condensation? Aldol condensation. Now how? That I am going to write it and show it to you. But the conditions, you remember it. So, alpha hydrogen atom. So which compound has got alpha hydrogen atom? Basically, acetaldehyde has got, formaldehyde has not got, because formaldehyde HCHO, it does not have any alpha hydrogen atom. Alright, benzaldehyde has not got any alpha hydrogen atom. Alright, benzaldehyde, benzene ring CHO, no alpha hydrogen atom. So acetaldehyde has got alpha, acetone has got alpha, or any other higher aldehydes like propanaldehyde or what you can say diethyl ketone, it has also got alpha hydrogen atom. Alright, so the compound which have got alpha hydrogen atom will undergo this particular reaction, so to say. Now I am starting with acetaldehyde only, CH3CHO. This is one molecule, and another molecule of CH3CHO I will be writing in this way. Why? You will see that is in presence of dilute NaOH. What is going to happen is that, or dilute any other alkali content, this alpha hydrogen atom goes here to form the condensation product. This alpha hydrogen, either this or this, anyone will go here and will get added here. So I said now that is it is going to form a condensed product. So it will be OH and this H I have written it here below. So one bond is there. Now this bond combines with this carbon atom. Alright, and what is going to form? CH, and here it is CHO. As you can see, CH3C, this H comes here, so it is OH, and this H comes below, that is H, and this bond comes with this particular carbon atom to form CH2CHO. So why it is called aldol? Because you can see we are having an aldehyde group and alcoholic group, so hence together it is called as aldol. Aldol, ALDOL. Alright, so this is called as aldol in general. Aldol, because we have got an aldehyde and alcoholic group. Fine. Now, but the IUPAC name is not that. IUPAC name is 1, 2, 3, 4. So 3-hydroxybutanol. The IUPAC name is 3-hydroxybutanol. We can say that. Again, I repeat, 3-hydroxybutanol. We can say. Now, when I will be heating with dilute HCl, this particular one, if I will be heating, if I am using this word, if I will be heating with dilute HCl, then what is going to happen? Water will be released, HOH. See, water is released. How water is released? You know that OH minus goes here, this pair of electron comes here, so H plus, OH minus, water is released. Why water is released? Because dilute HCl, it is going to absorb water. Alright, more and more of water, and hence what I am going to get the product? CH3, here is CH, double bond CH, because this bond comes here, double bond CH, single bond CHO. We can say that. We get this product. And water is released. If I am heating with dilute HCl further, then only this particular product is being formed. We can say that. What is this name of this particular product? It is called as but-2-in-1-al. IUPAC name. But, see 1, 2, 3, 4. But, 2 in, second position in, and first position al. But-2-in-1-al. Or the common name is crotonaldehyde. Got it? Crotonaldehyde. CROTONALDEHYDE. CROTONAL, crotonaldehyde, we can say that. Clear? In this way, we can carry out the reactions by using acetone. Alright, here. Acetone, I can take it here. CH3CO, CH3. Alright, I can take. And we can carry out the reactions in this particular way. And we can do that is any with any aldehyde and ketone. But remember that it should contain alpha hydrogen atom. It should be. Alright, it should contain. Now, if you are taking, alright, now this is known as simple aldol condensation. This reaction is called simple aldol condensation. But if you are taking two different aldehydes, or you are taking two different ketones, or suppose you are taking two compounds in which one compound has got alpha, other does not, then that is called as crossed aldol condensation. Crossed aldol condensation, we can say that. Again I repeat, suppose you have taken two different aldehydes. Here I have taken two same aldehydes, isn't it? Acetaldehyde, but I am taking two different aldehyde. Suppose I am taking formaldehyde and acetaldehyde, or I am taking benzaldehyde and acetaldehyde. It can be done in crossed aldol condensation. In crossed aldol condensation, it is not necessary that both the compounds should have alpha hydrogen atom. It is not necessary. One of the compounds can have alpha and other may not be. Or you are taking one that is acetaldehyde, another acetone. We can take that also can be taken. So that is called as crossed aldol condensation. That is known as when two different aldehydes or two different ketones, or one aldehyde and one ketone is being taken. That's said to be as crossed. Two different, we can say that. Let me write and show it to you. See here. Suppose I have taken here benzaldehyde. Alright, and here I have taken acetaldehyde. Benzaldehyde will not undergo aldol condensation, but if you combine with acetaldehyde, then it will go. Alright, see how it is. See here, look here. So it is CHO, here it is. Now this alpha hydrogen atom goes here in presence of dilute NaOH. Alright, condition remains the same in presence of dilute NaOH. So what is going to happen here? Let me write it smaller one, then it will be done. So dilute NaOH. Fine. Then what it will be done? Condensation product is going to form. Here COH and it is H. Alright, clear. And here it will be CH2 and here it will be CHO. Okay, we can say in this particular way the reaction is going to take place. Followed. So this is what is the name of this particular product. I think you count from here 1, 2, 3. So you will be getting what is that? See here 3 carbon atoms is there. So hence we will be getting 1, 2, 3. So it is nothing but 3-phenyl. Third position it is phenyl. Third position is hydroxy. So 3-hydroxy, 3-phenyl propanol, we can say that. Again, if you are heating with dilute HCl, if you are heating it, what will happen here? HOH will be released. When HOH will be released, what you will be getting it? That is here, that is nothing but CH, double bond CH, single bond CHO. This compound is known as cinnamaldehyde. It is known as cinnamaldehyde, CINNAMALDEHYDE. That is cinnamaldehyde, you will be getting it. Or 3-phenyl, 1, 2, 3, 3-phenyl prop 2 in 1-al. We can say that. Prop 1, 2, 3. Prop 2 in 1-al. We can say that. So this is coming under crossed aldol condensation. Alright, you can do with any other ketones and what you can say aldehydes you can take and carry out this particular reaction, so to say, we can say. So now next is if I take here two other, that is reactant, if I take, then we will be getting a named reaction. What is that? Let us see. What is that? So let us take here that is one benzaldehyde and one acetophenone. Both are aromatic. Alright, benzaldehyde and acetophenone. Now see here, benzaldehyde does not contain alpha, but acetophenone does. CH3, CO, then benzene ring. Alright, C6H5. CO, benzene ring, COCH3. Now here same thing, same process. Just for the name of that particular reaction, I am writing it. What is the name? I will tell you. What is the name of that particular reaction? After this I write, I will tell you. So what is going to happen here? You know it, CH, here one OH will be there. Got it? Let me write it smaller one. I am not getting space. COH, this H comes here. Now CH2 and here it is CHO. Alright, we get this. Fine. Now again same thing, when it is heated with dilute HCl and heated, what will be happening here? One H from here, or if I write it in this way, then it will be easier for you to understand. That is H here and one more H here. So HOH goes, and what is the product I will be getting it? The product will be that is CH double bond CH single bond. What is that? Wait. I have done a mistake here. That is not CHO. Here it will be CH2CO benzene ring. Alright, in this way. This H goes here. So it is COH, then CH2, then CO benzene ring. Correct. Now I am correct. So here it will be this HOH goes. So CH double bond CH. Then single bond C double bond O, then benzene ring. You get this product. We can say that. This product you get it. So what is this? We don't have any common name for it, but we can say an IPC name. That is first, second, third. So 1,3-diphenyl. Alright. First position 1-phenyl, third position 1-phenyl. So 1,3-diphenyl prop 2 in. 1,2 because this is a functional group, isn't it? Prop 2 in, that is 1 own ketone series. Clear? So this is the final product, you get it. And the name of the reaction, of course, yes, water will be released. Understood? H2O. And the name of the reaction is Claisen, SCLISEN, Claisen-Schmidt, SCHMIDT, Claisen-Schmidt reaction. Alright, Claisen-Schmidt reaction is said to be, or condensation reaction. Claisen-Schmidt condensation reaction, so to say, we can say that, where we take benzaldehyde and acetophenol and we carry out these particular reactions. Okay, so I think it's clear what is condensation reaction, what is your that is halogenation reactions. I have told you, means one part of condensation is over, that is aldol condensation. Alright, we have done it. Now we will come to the next type of. Thank you.